Hi everyone, this video is on exercise 9J question 10. We have a circle and its radius is increasing at a constant rate of 0.4 centimeters per second. In part A, we need to find dc by dt where c is the circumference of the circle, and then we need to interpret this value in the context of the model. Okay, so the same as the previous questions, we had some similar questions like this. They were at the beginning of this exercise, and the very first thing is just writing down some smaller steps first before solving the question, just to get an idea of what's going on. First of all, we have the circumference of the circle, so let's just write down what is the formula of the circumference of the circle, and that's simply 2 pi r. So this is the circumference of the circle. Now, as you can see, we have two variables in terms of the circumference. One is c, the other one is r. So we can find the CDR at some point. Okay, now the next thing is, and interestingly, we are actually asked to find dCdt. So dCdt is what we want to find. Now our job is to find what should be in the right hand side so that we can find dCdt. Okay, and I just mentioned that we have C and R, and from the formula of the circumference, we can find the CDR. But why? Why are we finding that? Is it just because we have a formula and we just do that randomly? So the answer is because these questions are most of the times chain rule questions. And in order to use chain rule to find the CDT, we need to find, for instance, the CDR. As you can see, we can easily find that from the formula. And then the second component here that will help us to find the CDT is having the RDT. Because if we have the RDT, then the DRs will be cancelled out, and then we'll only have dc by dt. And actually, now the question is, what is dRdt then? Because dr is easily found, right? So dc by dr is equal to the derivative of 2 pi r with respect to r is basically just 2 pi. Okay, now we have this. We also need to find the RDT, and the good news is they have given us. So it says the radius of the circle is increasing at a constant rate of 0.4 centimeters per second. So the rate of change of the radius with respect to time is 0.5 centimeters. So it's just saying that the RDT is equal to 0.4 centimeters. Now that we have everything, we can easily find dc by dt. So dc by dr is equal to 2 pi times dr by dt is 0.4, and finally we get 0.8 pi centimeters per second. Just let's be consistent with the units, because the circumference has a unit of centimeter, and then the RDT is per second, basically the unit of that. Okay, this is the answer to part A. Also, it has a interpretation question at the end. So what this means is that the circumference of the circle increases at a constant rate of 0.8 pi centimeters per second. So that's the meaning, basically. This is just the rate of increase of the circumference over time. So that's the meaning of 0.8 centimeters per second. Okay, now part B. Find the rate at which the area of the circle is increasing when the radius is 10 centimeters. So this question is actually very similar to the previous part. So we want to find the rate at which the area increases. Basically, this time we want to find the ADR. Sorry, the ADT. That's what we want to find in this case, the ADT. So, in the previous one, we wanted to find the CDT, which is just, the rate of increase of the circumference over time. But now we want to find the rate of increase of the the area with respect to time. Again, we need another chain rule. So before writing down the chain rule, let's just write down the area of a circle, which is pi r squared. So this allows us to easily find the ADR, because this is going to be useful. So 2 pi r is the derivative. Now, in order to find the ADT, we can use obviously the ADR, and then times dr dt. So again, similar to the previous question, we have the ADR, we just found that. Another question is whether we have the RDT. And the answer is actually straightforward because just remember that this is just the same DRDT that we were given at the beginning of the question. So that's the rate of change of radius with respect to time. So basically we have everything. The only thing that you need to note that in this case they are asking us to find the exact value of the rate of change when the radius is 10 centimeters. So you will see how this is going to be used in a few moments. So let's substitute everything that we have. So the ADR, we just found out that's 2 pi r, and then the RDT is 0.4. So once again, this time actually is slightly different because the answer to this is 0.8 pi r. Last time we just had 0.8 pi. Now, as you can see here, we have we have r, and they have asked us to find the rate when r is 10 centimeters. So it's just a simple substitution. When r is equal to 10 centimeters, then the ADT, which is the rate, is equal to 0.8 pi times 10, which is just 8 pi. The unit is also important, centimeters squared per second, because this is to do with the area, so that's why we have centimeters squared. Okay, so this was again very similar to the previous part. We just had a final substitution at the end. Okay, and finally part C. Find the radius of the circle when its area is increasing at a rate of 20 centimeters squared per second. Okay, so from the previous part, we found basically the ADT, or the rate of change of the area, right? So we found the ADT. And we found that, in a general sense, the ADT is equal to 0.8 pi r. This is always true based on the value of the r. This is the rate of change of the area with respect to time. Okay, now what the question is saying here is that find the radius of the circle. So radius is the unknown in this question. When its area is increasing, this is about the rate of change of the area, or the ADT, at the rate of 20 centimeters squared per second. So essentially it's saying that when the ADT is equal to 20, then what is the value of r? So it's basically asking that find the value of r when the rate of a change of the area is 20 centimeters squared per second. So what this simply means is that we just need to basically solve an equation, right? Because we know that the ADT is always equal to 0.8 pi r, and in this specific case that the ADT is equal to 20, we want to find the value of the radius. So we just solve the equation. 0.8 pi r is equal to 20, and now simply we just divide both sides by 0.8 pi to get, we get then 25 over pi centimeters. So now this is the answer basically. So this means that the radius, when the radius is 25 over pi centimeters, then the ADT is equal to 20, or the rate of change of the area. Okay, that's it for this video, and thank you for watching.